Hello class, and welcome to Notes 7.G.4, Areas of Circles. You will notice we've covered quite a bit of this standard, and that's because the standard has a lot of different parts to it, so we've been doing it for quite a while. This standard, we are covering the portion that says know the formulas for the area and circumference of a circle and use them to solve problems. Give an informal derivation of the relationship between the circumference and the area of the circle. For our vocabulary today, we simply have area of a circle, the product of pi, and the square of the radius. And that formula is A equals pi r squared. Please make sure you write down this formula, circle it, star it, do whatever you need to do to make sure you remember it. I would definitely put it in a little bubble. Okay, also notice that we do not have a diameter formula like we did with circumference. We could use either area or diameter. This time we can only use, radius or diameter. This time we can only use the radius. So if you're given the diameter, you will have to change it so that it becomes the radius. So let's take a look at our first teacher example. Teacher example 1, pencils down. In the first problem we have our radius, 7 centimeters. Find the area of the circle. Use 22/7 for pi. Remember to watch out for this. I know a lot of students had trouble with this on circumference. It does tell you what to use for pi, so you must use 22/7. Okay, so we can go ahead and start out taking a look at an estimate. I know if my radius is 7, 7 squared is going to be about 50, and pi is about 3. So my answer should be around 150. It's not going to be exact, but that's a quick way of checking my answer. Okay, so let's go ahead. First things first, we always write the formula. A equals pi r squared. And remember that a good way of keeping track of the difference between area and circumference is the area formula has a square in it because area answers are always squared. So that's a little trick for remembering which one's which. Now we need to plug our numbers in. Remember for pi we're using 22/7 and our radius is 7 squared. Okay, we do need to turn that 7 squared into 49 first, then we can go ahead and cross cancel. And we notice the 7 becomes 1, the 49 becomes 7, and if it helps you, put the 49 over 1 to help you keep your fractions organized. Now I've gotten rid of the denominators, they've just become 1, so I don't need to write them, and I can simply multiply 22 times 7, and end up with 154. Okay, so the area is about 154 square centimeters. When you write it out in words, you always put the square first. If you're writing it out simply using numbers, you'd have cm with an exponent of 2. Okay, and then going back and checking our estimate was that it should have been about 150. 154 is pretty close to 150, so our answer is reasonable. And again, that's a real quick, easy way of checking your work. Okay, looking at problem B, this time we're given 26 inches is the diameter. You want to be very careful of this. A very common mistake is for students to use 26 in their problem. Remember, our formula only includes the radius, so I cannot use 26. I need to turn that into a radius. So if we take a look here, 26 divided by 2 is going to be 13 inches, because as we know, the radius is half the diameter. Now, using the radius, I can go ahead and solve my problem. Estimating 13 squared is around 170, pi is around 3, so my answer should be around 510. Okay, so I plug in my formula, plug my numbers in. Notice this time it told us to use 3.14 for pi, so we're not using 22/7 this time. Now we can go ahead and square 13. And notice, order of operations tells us we need to do the exponent first before the multiplication. Be very careful there. You have to follow order of operations. Even if we don't talk about it every time, you always follow that order of operations. Okay, we end up with 530 and 66 hundredths. Writing our complete answer, we do need that square inches on there. And then we can go back and check our answer and make sure it's reasonable. And yes, that is pretty close to 510. Okay, let's go ahead and go on to the first student practice. Find the area of a circle with a radius of 6 feet. Use 3.14 for pi. And for the second problem, find the area of a circle with a diameter of 28 meters. Use 22/7 for pi. Watch out for number 2. You are given the diameter, not the radius. Go ahead and press pause, press play when you're ready to see your answers. Okay, let's take a quick look here. Notice I've set them up for you first. So make sure you look at the setup. We must write the formula every time. Plug our numbers in. Take care of the exponent first, square that radius first. On number 2, notice I had to take care of find my radius first, so take care of that division. Okay, and on number 2 it also said to use 22/7 for pi, so do be careful. And we have our final answers here. Notice I have my units squared on both of these. Okay, and if you didn't understand any of that, make sure you do go back and re-watch. Let's move on to teacher example 2. This one's a real quick example. You want to find the distance of a monster truck travels when the tires make one 360-degree rotation. Which best describes this distance? So what you want to think about is the truck is rolling forward just enough for the wheels to turn around once. So if we're going around the outside of the wheel, or the tire, one rotation is the same as the distance around the tire. So the circumference of the tire best describes this distance in one rotation. Notice area would be inside, say we were painting the tire. But since we're going around the outside once, it is the circumference. So the correct answer would be C. Okay, let's take a look at student practice 2. This one should be a nice quick one. You want to find the height of one of the tires. Which measurement would best describe the height? Now remember, I'm not trying to actually find the height. I'm trying to think of what I would be looking for in order to do so. So go ahead and press pause while you think. Press play when you're ready to see your answers. Okay, welcome back. If we take a look, the height of the tire is going to be from top to bottom. So we're looking at that height there across the entire circle. So obviously that is going to be the diameter of the tire. Okay, find our teacher example. Find the area of the semicircular orchestra pit. Now remember, with circumference, we had to find the circumference around the rounded edge of the semicircle. We also had to find this perimeter of this straight edge right here. For area, it's the entire inside. So it does make it a little easier. We don't have to do that extra step of adding this piece on. So this is a little bit faster. The area of the orchestra pit is 1/2 the area of a circle with a diameter of 30 feet. So notice we have half of a circle. Okay, the radius of the circle then would have to be half of 30, which would be 15. Now, I have my formula. Notice I don't want the area of the entire circle. I want to divide it by 2 because I want half the area. So that's why we've got all this divided by 2. We can plug pi in, and notice it didn't say what to use for pi, so the easiest thing would be 3.14. We've got our 15 squared here. We've now squared 15, then taken care of our multiplication, and finally our division. So make sure you're following each of those steps. Okay, of course I cannot leave my answer like this. It is a word problem. We do need words in our answer. The area of the orchestra pit is about 353 25 square feet. Okay, let's go ahead and give you some practice with doing those semicircles. Remember, you're using your same area formula on each of these. The only difference is you're cutting them in half. You're using half that area. Okay, go ahead and press pause. Press play when you're ready to see your answers. Okay, let's take a look and see how you did with the setup first. Notice I have them set up here for you. Watch out on both 4 and 5. Hopefully you caught that you did need to cut the diameter in half first. So you cut the diameter in half for each of those to find the radius. You will notice on number 4, I went ahead and did that division first, and it still does come out with the same answer. I could have multiplied these together first and then divided the whole thing, but it will still give me that same answer. Here, it wasn't easy enough to do this in my head, so I simply did that multiplication first, and same thing with problem 6. And then you can go ahead and check your final answer right down here, and you will see we've included the units, meters squared, yards squared, and centimeters squared. So make sure you're working very carefully, check your answers, and go ahead and go on to the quiz.